In the last video about tessellation, we created this sandy plane. Now, tessellation is cool in Unreal, and it looks alright, but there's problems with it, such as that flickering that sometimes happens, the collision is always off, and it's definitely not performance friendly. The best way to get around this problem and still have great looking tessellation is to tessellate the object in a separate tool and then bring it into Unreal. That's what we're going to use Blender for. Here's the same plane that I tessellated in Blender for a cinematic shot. Now this has lots of vertices, but with this modifier here I can choose to bring down the vertices a lot, and the quality difference is barely noticeable. In this video I'm going to walk you through this entire process and we'll bring it into Unreal and see how it does. To start off this project, we're going to need to bring these textures from the material or whatever material that you're using into the folder so that we can bring them into Blender. To do that, select them all by clicking one and shift clicking the one on the far end, right click, asset actions, and then you're going to click export and save them to a location. Open up a new scene in Blender, delete the default cube and add in a plane. Now you're going to open up a new window, navigate to shader editor, press new to add a new material to this, and we're going to add in the albedo texture. So go back to your content, find the albedo, and drop it in like so. Now this is the Blender shader editor, and all of these nodes are meant to help you visualize materials on your models. These little circles are called pins, and you can drop them into each other from different nodes to create different results. So what I'm going to have you do is drag the color pin from the texture into the base color of the principled BSDF, that is the master shader for this plane. The BSDF goes into the surface of the material output, and that tells this plane what to look like when we render the image. And so I'm going to go press Z and then press rendered, and we'll be able to see the texture on our plane here. But I'd rather scale this up by pressing S, and I'll choose 10 so that it's easier to see. You can go ahead and close the shader editor right now. We won't need it. I just wanted to see this so that we can visualize how it's going to look with a texture on it. Go back into solid mode by pressing Z and clicking on solid. Now everything will be gray again. Now you're going to go into the modifiers tab, click add modifier, and choose a subdivision surface. Now we're going to crank this up a lot, probably to about 4 to start out with, and you will see that it turns into a circle. And if we go into wireframe by pressing Z and wireframe, we can see that we just added a lot of geometry. But we don't want it to be a circle because that's just not what we were going for. We were going for a square plane. So to bring it back, go into edit mode and press Shift E and zoom out. And that's going to crease all of the edges just like you would crease a sheet of paper so that it turns square again. And now you can go into rendered to check and make sure that nothing looks off. And now that we've done that, it's time to add another modifier. Go ahead and add a deform displace modifier. Now you will see at first it's going to jump up pretty high, but you're going to click new texture and you're going to click this icon right here. It stands for properties. Now you're going to click open image and drag in your displacement image that you exported. Click open image and this is going to happen. Turn the color space from sRGB to non-color to make sure that we don't have any weird results. Go back to modifiers and change the texture coordinates to UV. Next I'm going to have you go to object and shade smooth, and then press Z and go to Material Preview. This is the view that we're going to be using to preview our tessellation with the textures so that we can make sure it's looking okay. Now, as you can see, the effect is immediately very jarring, but we can affect that by turning down the strength here. So click on this little arrow and it'll bring it down 0.1 at a time, and I'd bring it down to something pretty low to start out with, maybe a 0.3. Okay, and you can click this icon up here to disable the grid, so that we can see what it looks like. Now, this may be a good time to bring back the shader editor and drop in another texture. Go back into your content and find the roughness map, drop it in, change the color space in this node to non-color, and then drag the color pin into the roughness value of the principled BSDF. Now we'll have correct roughness on this preview. If you want a more realistic preview, you can press Z and go into rendered mode. I'm going to duplicate the lights around in this scene so that we can get a better preview. To do that, I'm going to select this default light, press Shift D to duplicate it, and press Shift Z to move it around on every axis except Z. do that twice. I position them in a 3-point pattern around the plane, go back into rendered mode, and this is what we have. It has less geometry than the Unreal version, and yet I think it looks better, and it is going to perform much, much better, significantly better. Let's adjust the settings on these modifiers. First of all, I want to add another subdivision surface modifier, except this one is to smooth out what we did with the first one. So now there's going to be no sharp edges, because we want smooth rolling dunes. We don't need any sharp edges. And now we can adjust the strength to go a little higher, because the additional subdivision surface smooths it out. Go into wireframe to see the geometry that you have. As you can see, it's all quads. It's going to perform very, very well in the engine. We may even be able to decrease the subdivision surface once if you don't need very detailed tessellation. As you can see, this is very, very few vertices, but it still has real depth based on an image. I'm going to turn mine up a bit, just because I really like detailed tessellation. And if you have the performance to spend, you can turn it up again, except then you're going to need to turn down the strength a bit. But it's going to be very, very detailed if you do that. I'm going to stick with 4 because I feel like that's where most people are going to end up. Now, one thing I need to get out of the way before I move on is that your Quixel Megascans license covers your use for Unreal Engine only. That being said, there is a clause in the terms that allows you to use external tools as long as it's for the purpose of Unreal Engine. So that means you can't make any renders with their assets or their textures, and you can't deliver anything unless it's using Unreal. So this is fair game because we are creating it to bring into Unreal. As long as the final product is in Unreal, you are within the terms. So just make sure that you're not exporting textures from Unreal and then creating personal renders in Blender with them. Alright, this looks pretty cool, but I want to mess around with some higher detail stuff. So I'm going to bring up the viewport and the subdivisions again. Now, if we go into wireframe, we can see that this is pretty detailed and probably wouldn't do as is for a game. That is, until we do what I'm about to show you. First, you're going to apply each modifier one at a time. Now, if you go into edit mode, which you may not want to do because there's a lot of geometry in here, you'll see that there is a ton of vertices, 16,000 to be exact. You can see the exact number down here. But if you add a decimate modifier, you're going to have some different results. Here we have a slider that determines the ratio of faces it will generate based on the face count as is. Now right now we have 16,000 faces, but if we decrease this, you will see minimal changes in geometry and style, but huge changes in face count. So if you're using this for a game, I would recommend just bringing it down all the way to 0.1, and you may see some weird artifacts like these shadows appearing on the sides, but we'll be able to fix those. So I just want to bring this down to some manageable amount, so I could bring it down to 0.05, and then we have this crazy low poly tessellated mesh that still looks pretty good because we have shade smooth turned on. Keep in mind you may want to add another subdivision surface at the end of that just to flatten out any changes that get made so that we don't have any weird sharp corners. That by itself is going to get rid of most of the artifacts that we get, but it's also going to bring up the amount of geometry again. So I just settled on 0.05 as a ratio and a 1 as far as viewport subdivision. So I'm going to apply both of those, and now this is what we have. If we go into wireframe, you can see that we still have a lot of vertices, so I'm actually going to go ahead and decimate it once again. And I'm going to just do a little bit to get rid of the extra faces that we don't need, and it's going to try its best to preserve all of the major shapes. So I just brought it down to a manageable 1,500 vertices, and I can barely tell the difference from when it was at like 200,000. Now this works really well even in a close-up shot, and if it was far away, or if we're in a third person maybe, you could add another decimate modifier and bring it down even further until you can still see the major details, but it's a much lower vertex count. See here it is 573, that's incredible. But we're going to have these strange shadows that appear sometimes, and so we're going to have to fix those. Now these are caused by just strange vertices that end up in the middle of edges and things like that. So to fix that, we're going to do some cleaning up. Select the entire mesh, go to Mesh, Clean Up. First, we're going to delete loose, and if there's any loose geometry, it will delete it. And for the next cleanup operation, we're going to have to do a little bit of messing around with some complex settings, so bear with me. First, you're going to click this magnet, which is going to make it so that we can snap things to each other while we're moving them around or transforming them. Then click on this button here, which is for snapping, and choose Vertex. Now watch this. If I select one of these vertices in one of the spots that looks weird, and I press G, and I hover over another vertex, it will immediately snap to it. So go around and find all the weird shading artifacts, just grab a vertex, and snap it to another one. Now you may still see some artifacts, but we're going to fix that in the next step of this small process here. So that appears to be the main one. Now watch this. I'm going to select everything, go to Mesh, Clean Up, and Merge by Distance. And you're going to see that it removed a bunch of vertices. Now if I go back, we have no artifacts. Now you can go through and clean and optimize as much as you would like. I'm going to go ahead and try to bring this thing into Unreal, and we'll see how it performs. Remember to delete all the cameras and lights when you go and bring it into Unreal. Now here are the two compared side by side. This is the one we made in Blender. This is the Unreal Engine one. And whichever one you prefer, this one ends up being the most optimized for game developers, especially when we go into wireframe mode here. And you can see that this has much less geometry than this. Not only that, but if we press play, I can't run into this. There's no collision for this. There's also Z fighting, so you're going to get all this flickering. However, with this one, you can run into it, no problem. There's no flickering. And the best part about this one is that it's more easily scalable. We can easily go back and undo what we did with the decimate modifier to make this as smooth as possible. If we want, we could make one with 1,000,000 vertices. In Unreal, they set all these limits. But if you want something truly cinematic and you have the performance spend for it, no matter the case, it's always a better idea to pre-tessellate in something like Blender. So I'm very hopeful that you found this to be helpful. I know that a lot of people are concerned about performance, and I know that a lot of courses don't end up covering that. So I want to make sure that you get the best learning experience possible. So I apologize if this video was long-winded, but this is something that will truly help you out if you set out to create environments like this. So with that, I will see you in the next lecture.